Right, good evening. I'm here at the Air Force Association National Convention, and I'd like to brief you on our topic, uncertainty quantification, that we're proposing for the fiscal year 2015 Prospector BAA. We're teamed with IBM on this project, and I would like to take you through. We've been studying complex systems. And in complex systems, we see some trends. We see some trends that historically we have weapon systems that tend to be single mission. They tend to be hierarchical. They tend to be very structured. And as we look into the future, we see complex systems, system of systems that are very unstructured, decentralized control, and very much different than the structured systems of the past. That's led us in our research to think about how do we model and simulate these complex systems. We've built, through a couple of small business innovative research projects, a technique that we call model simulation analysis looping. And what we're really looking at is the real world and all of the various non-linear and unstructured inputs that come from the real world, modeling that in a graph database, being able to simulate that model through a graph, collect all that data in the graph database. That gives us a very rich resource of data to do data analytics, and then we're able to iterate on that, check with the real world, and we have a very powerful technique here for using data analytics, cognitive processing, a whole toolbox of various statistical and parametric tools, and I'll show you one of those in just a second. At any rate, in our work, we've done the research to build an application, and you can see it here in an activity diagram, a SysML activity diagram. Again, we're going from the real world over on the left, moving through a modeling loop and then into a simulation loop. We build the mission model, and then we build specific mission threads. And at the very inside of the loop is where we perform uncertainty quantification. It's this uncertainty quantification that tells us about unknowns, tells us about risk. And this is the part that we think is a contributor to the 2015 Prospector. Once we take that SysML model, we've actually implemented that in a graph. So this is a graph of that SysML model. It has all of the components that we need to do our model simulation analysis looping technique on our application. And I've got something to show you here that gives you a little bit of a sense of what we're doing. This is a network, and the network is showing us how a graph works and how we set up our graph modeling. This happens to be a basic electrical power network, and it's showing the complex nature, the nodes and edges in the graph. And what we do is build that model, and that model then allows us to do a lot of parametrics and statistics in our power and energy use case. And I want to show you some of that. So that model decomposes like this, and we're using a IEEE 37 bus problem that's well received in the energy domain. We're doing our simulation on it. This is out of the graph database. We can also do some parametric statistical analysis. This is actually an uncertainty quantification measure of that performance surface using Sandia National Labs Dakota tool. Again, we can loop back through that, we can change, we can react to what the real world's telling us, we can react to what the performance is telling us, and have a very flexible tool in order to do the modeling and simulation we like. The benefits we see in this technique is that we're extending current methodology. We're using some of the classical methods, but we're extending them into graphs, into networks, into things that can connect nodes and edges across complex systems in very nonlinear methods so that we can do the data analytics on it. Leveraging emerging technologies, graph computing. Some of the techniques we're using today weren't available to us 5 years ago. So bringing in new technologies, bringing in new information technology is something that we're really after in this BAA, as well as got to think. We got to think today in these complex systems. We've got to add the engineering back into our design of complex systems. So here's our schedule. We're going through and building an intelligence use case, just like we built our power and energy use case. We'll build a mission model in about a 60-day period. We'll do our simulation, modeling, analysis, looping. We'll be able to demonstrate that to you, the customer, and then we'll have a closeout meeting and a final report with all of the data. Well, I'd like to thank you very much for considering our project in the 2015 Prospector BAA. Thank you.